In this video, we're going to be looking at the definition and the properties of a rectangle, and we're going to use those properties in order for us to figure out whether or not a given example is a rectangle. So a rectangle, I'll write this down, a rectangle is a parallelogram with 4 right angles. So let's write that down. A rectangle is a parallelogram with 4 right angles. And now just to remind you of what a parallelogram is. A parallelogram has 2 pairs of parallel sides. So now we're talking about a figure with 2 pairs of parallel sides and the angles are all right. Not all right, but all right angles. All right, anyway, my little corny joke. So some of the properties of a rectangle that we should know. All 4 angles are right angles. We just spoke about that. And this is every single time. All 4 angles are always right. Another property that we need to know is that the opposite sides are parallel and congruent, and that's actually true for a parallelogram as well, but very important for a rectangle. So opposite sides are parallel and congruent, just like a parallelogram. We need to know that the consecutive angles are supplementary, and that's kind of a given since everything is 90 degrees. 90 gives you 180, but that's okay, we'll write it down. So consecutive angles are are supplementary. They're also congruent because they're 90 degrees each. And something important, the diagonals bisect each other, as they do in the parallelogram. Now, in addition to the fact that the diagonals bisect each other, in particular for a rectangle, it's important to know that the diagonals are going to be congruent. And this is the diagonal of rectangle theorem. This is the diagonals of rectangle theorem. So the diagonals of a rectangle will always be congruent. The measures will always be equal to each other. All right, so now we know all these facts laying out on the page. Let's actually use this information and try and figure out if our example that I'm going to show you is in fact a rectangle. All right, so here we have a quadrilateral, and we want to figure out whether or not it is a rectangle. So there are a couple ways we could go about doing this, but this question specifically wants us to use the distance formula in order to accomplish this. So, a couple things we know about the lengths in a rectangle. We know that the opposite lengths have to be congruent to each other. So that has to be congruent, to that. And this has to be congruent to this. We also know that the diagonals have to be congruent to each other. So if that's a diagonal here, and that's a diagonal here, both those diagonals have to be congruent to each other. So we're actually going to use the distance formula to figure out if these 3 pairs of lines are congruent to each other. So, I'll write down what the 3 pairs of lines are. PQ has to be congruent to the opposite side SR. And again, we don't know if this is true, so I'm going to put that question mark here. PS has to be congruent to the opposite side QR. And we don't know if that's true, so question mark. And the diagonals, that's not a P. So PR would have to also be congruent to SQ. And if these 3 things are true, then we know that we have a parallelogram and a rectangle. Actually, we know we have a rectangle. All right, so let's go about using our distance formula and figuring this stuff out. So there we go. Forgot those segment symbols there. All right, so let's go ahead and do the distance formula. Use the distance formula, which, just to remind you, distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so in order to find the distance of PQ, we would just plug directly into that formula. And I'm assuming that you already know how to use the formula, so I'm not going to be very explicit. I'm just going to plug in here, negative 5 minus 1 squared plus 3 minus negative 1 squared. And when you work that out, you should get the square root of 52. All right, do the same thing for RS and see, or SR, sorry, and see if you get the same answer. So SR is equal to, we have here, negative 1 minus negative 7 squared plus negative 4 minus 0 squared, and that does in fact give you root 52. So our first condition is true. We no longer are questioning whether PQ is congruent to SR. We are now sure. So now we have to go ahead and test the other two pairs. And since I've run out of space, I'm just going to do it on the next page. All right, so we already tested to see that PQ and SR are congruent, and they are in fact congruent. So now we're ready to check to see if PS and QR are congruent. So PS is equal to the square root of negative 5 minus negative 7 squared plus 3 minus 0 squared. And again, I'm assuming that you already know how to use the distance formula, and you should get that PS is equal to the square root of 13. All right, now we can go ahead and test to see if QR is equal to the same thing. So QR is equal to the square root of 1 minus negative 1 squared plus negative 1 minus negative 4 squared. And when you work that all out, you should actually get root 13, which means now we know that our opposite sides are both equal to each other. So now all we have to test is to see if the diagonals are equal to each other. So are PR and SQ congruent? Let's see. All right, so PR is equal to, and again, I'm just using the distance formula because that's what the question asked for, negative 5 minus negative 1 squared plus 3 minus negative 4 squared. And when you work that all out, you should get the square root of 65. And finally, QS is equal to the square root of 1 minus negative 7 squared plus negative 1 minus 0 squared. And again, when you work that all out, you should actually get root 65. So the diagonals are also equal. So the opposite sides are equal, the diagonals are equal, everything that we want to be equal is equal. So this is actually, yes, it is a rectangle. And we're done.